welcome back to my channel. Today we're going to be doing something a little bit different. This is my final project for CSCA 5632, aka unsupervised machine learning. So let's get into the project. So basically the goal of this project was to cluster different cryptocurrency assets. So cryptocurrencies can be pretty volatile, and the goal is to cluster these assets based on their various attributes. So for example, price, percentages, market cap, total supply, and to group them into categories to answer the question like, are there any meaningful data-driven groups among these assets that can be uncovered using unsupervised learning techniques? So that's the overall goal of this project. Again, to identify natural groupings. So some coins are volatile, some coins are highly traded, and we don't want to rely on any predefined labels because that would be supervised learning. So this becomes unsupervised. And again, there's no target variable, there's no predicted output. And throughout this project, I tried to compare different algorithms like k-means, agglomerative, and dbScan to see what kind of data we can uncover with each. And also wanted to mention that this data was completely fetched by myself, as we'll get into. So this data was taken from CoinMarketCap. So there's the top 50 coins that I took in terms of US dollars, and I basically hit their API. So you need an API key here, and I only printed the first because there's a lot of data, and these are some data type conversions from datetime, from string to datetime, and some data cleaning and dropping certain columns that are not necessary, like date added, for example. It's not really relevant. So these are the final columns that we care about, and this is what's displayed. So that is the data collection part. Again, just wanted to be clear that this data was scraped from CoinMarketCap. So only 50 records, but I think that's enough for this project. So on to step 2, part 2. This is a description of what the project is about. Basically what I just said. We want to identify natural groupings, to uncover insights about, okay, is Tron a stable coin? Is XRP a volatile coin? Is Bitcoin a stable coin? Etc. So are these meaningful groups that can be uncovered with unsupervised learning? So let's get into the meat of it, which is step 3, which is exploratory data analysis. And so basically this section is pretty important because it's more than just data cleaning, which we did up here. Basically, this is where we actually group the data to identify what's important and identify metrics like skew, like outliers, and basically just do a deep dive analysis on the data. So, and we want to prepare it so that we can run k-means, certain like these algorithms on it. So these are the columns that we had, and then this is just a for loop to basically plot the distributions for each feature. So there's something called kernel delivery estimation, KDE, which is used to give a smooth curve over the histogram that you'll see here. So for example, distribution of columns and frequency. This is the first chart. And again, it just helps visualize the skewness with features like number of market pairs or the market cap. So that's the first for loop. The second for loop is a box plot for outliers, basically highlights extreme values like in market cap. Bitcoin is obviously going to be one of them because that is nearly 65% of the total market cap. So that's why some of these have far right outliers. So box plots of COL. So box plot of COL. Let me see. But I think you get the idea. Basically, that's what it is, just outliers. And basically after that, this is just plotting everything. So after that, the third for loop is used to compress range and normalize skew distributions. So we use log 1p to basically avoid issues with trailing zeros, and again to compress the range. And this line is used to replace null values with column-wise mediums to robust the outliers, so we don't have the data, we want to kind of fill it in there. And then this is used to convert booleans to zeros to one for model compatibility, to make the transformation more data clean and numeric. So when we actually run k-means, those algorithms can work better. So that is the EDA part. So now on to step 4. Again, it's a lot of different charts here. I don't have time to go through all of them, and you can see the heat map here. So that just shows you the correlation between certain features. And okay, so this is the write-up for part 3, and let's go to the last but most important part, which is step 4. So this is the actual part where we apply k-means clustering and basically try to cluster the different models. So let's go over it. This is the data preparation steps. We only selected numerical features for clustering and applied some standardization using the standard scalar class to make all features comparable, and also set up the input data for X scaled to use in all clustering models. So for the k-means clustering, which is right here actually, we basically loop from 2 to 10 inclusive, because Python doesn't include that last one. And we want to store the silhouette score, so higher equals better cluster separation. And we want to pick the k with the best silhouette score. So basically this, we would be plotting the silhouette score here. And next, we also used agglomerative clustering. So that's the second algorithm. We want to compare the performance of all of them, which is the best linkage method, which was average actually, which produced slightly better, higher silhouette scores. So here we tried different linking strategies. So you have that parameter, linkage, and ward. So we tried all these different ones. We looped through this. And we computed the silhouette score to choose the best linkage method out of all of these. So the last but not least, dbScan. This one didn't perform very well, and basically what that means, it didn't perform any valid clusters at all. And basically we have a grid of dbScan hyperparameters called min sample values. And we want to check if the dbScan produces at least 2 clusters, because some of the configurations give only 1. So that would be -1 as the dummy value. And then we want to record the silhouette score for all the valid runs. And finally, we want to fit the models. Let me see. So basically we fit all the final versions of all 3 models using the best hyperparameters, and we produced cluster labels in terms of labels k-means, labels ago, and labels dscan. So right here, labels dbScan, ago, and k-means. And then the cluster evaluation summary. For each model, the silhouette score basically means how distinct the clusters are. And then we have the CH index, which is, so right here. The CH index is how well separated and dense the clusters are. So a higher CH is better. And then the DB index is basically lower is more compact, and we have clusters that are more well separated. And last but not least, we have our visualization using principal component analysis. So we tried to reduce the data to 2D, to two-dimensional using PCA so we can visualize it easily. And we plotted the k-means and the agglomerative and the DB scan clusters side by side to compare how distinct the clusters are. And then we profiled the clusters because we want to compute the mean, median, and count for each feature per cluster, and then also add the cluster labels to the original data frame, and also generate the bar plots for the average feature values per cluster. So the observations, for example, the cluster with the higher market pairs would be large coins, and the cluster with negative returns would be underperformers. So that is number 4, and then these are all the charts that we came up with. So what you'll see is that the silhouette score is 0.265. So k-means actually yielded moderately separated clusters with a clear structure and meaningful group sizes, as the largest cluster had, I think it was around 45 records. And then the PCA visualizations revealed a good spatial separation between the clusters. And for agglomerative clustering, so for agglomerative clustering, the best linkage method was average, and the silhouette score was 0.2 something, 0.28. So the median count was 0.45. Okay. So basically, overall, I know this is kind of hard to read. The agglomerative clustering has a slightly better silhouette score and much better Dave's Bolin score, so its clusters were more imbalanced. And in particular, 2 of the 3 clusters had only 1 data point each, suggesting possible overfitting or excessive fragmentation. And this is kind of hard to read, so I'm trying to find the chart for. So that's, you can see no valid DB scan clusters found. And then, okay, so yeah, this is what I was looking for. Okay, so as you can see, the average one had the best silhouette score. So the clusters were basically more imbalanced. And the DB scan results showed that agglomerative clustering had 0.54. Okay, so this is just lining up to what I'm saying. So lower is better here. And then this is, well, I'm not sure what that is, but the silhouette score is slightly higher than the silhouette score for k-means. And basically, we see a lot of overfitting because 2 of the 3 clusters had only 1 particular data point. So finally, the DB scan. Not sure why that's not displaying, but the DB scan, we tried all multiple combinations and it failed to produce any valid clusters. So all the configurations resulted in like less than 2 clusters, making the silhouette score impossible for DB scan. That's probably why we didn't print it here. And so basically, DB scan is not suitable for this data set, probably because there's a lot of sparse, aka empty data, and there's a lack of well-defined regions that are particularly dense. And so the conclusion is that k-means provided the most stable and interpretable clustering results, while agglomerative had marginally better silhouette and DB scores, but suffered from extreme imbalance and singleton clusters. And then the final recommendations was we wanted to use k-means with a parameter of 3 for segmenting data because it delivers useful cluster groupings to balance cohesion and separation. So I think that's about it for this project. So, yep, this is the write-up for part 4. Thank you for watching and stay tuned for more.